Okay, now we go to another topic, which is the high frequency response. Okay, this is the RC coupled circuit for the high frequency response. Okay, the circuit is different with the low frequency. So here this R and this is the C capacitor, V in and V out. So when we derive, we get the V out over V in, or a gain, is equal to 1 over 1 plus j omega RC. So from this equation, we can get the omega is equal to 1 over RC, or the frequency is equal to 1 over 2 pi RC. See, this formula is same with the low frequency. Okay. Now for the high frequency response, we need to find the point to draw the curve and also the asymptote. Okay, for the curve or the actual response, okay, the equation actually same with the low frequency response. Okay, can you see any difference, okay, from the previous low frequency response and with this one? All are same. Okay, the 20 negative 20 multiplied with log this one. However, okay, this F is different. For the low frequency, okay, for the low frequency, if you remember, the F1 is divided by F. For the high frequency, okay, now the F is, the frequency is like this. Okay, so the frequency is on top and it is at the bottom part. Okay, so only this difference between the low and high frequency. Okay, then you use the magnitude of again this formula to sketch the curve. Okay, step number 4. Then if the approximate analysis is used when this frequency is bigger than 1, the equation become like this. Okay, so it's same as the previous one. For the low frequency is F1 divided by F. For the high frequency, the F divided by F2. Okay, so it's a different, okay, versus this one. Then to plot a frequency in decibel, so we use this step. The first one, find the frequency, okay, we already get, and then second, sketch the asymptote, okay, using this formula. Okay, and then find the negative 3 dB point. Okay, and then we sketch the curve. Okay, so next, there is a little bit additional from the low frequency. For the high frequency response, the capacitance reactant Xc of the CE, CC and CS will be 0. Remember that, it will be 0. It means this capacitor will be short circuit and their values will not affect the calculation at this point. Okay, for this one, because the reactant will become 0. So you see in the AC equivalent circuit, there is no capacitors for the CE, CC and CS anymore. Okay, because they already converted into the into the short circuit. However, the other capacitive element will appear during the high frequency operation and will determine the high frequency characteristic of the amplifier. Those capacitors are wiring capacitance, this is a new capacitance, wiring capacitance CW in and CW out, one for input and one for output. Okay, we said wiring, so W is for wiring, where there are capacitance at the input and output terminal of the BJT device. Okay. Then second, the interelectrode between terminals capacitor. Okay, we name it interelectrode. This capacitor will be appear during high frequency response. So between terminal, between base and collector, we call it CBC. The capacitance between base and emitter, we call it CBE. Capacitance between collector and emitter, we call it CCE. Now, how does it look like, okay, for the interelectrode and wiring capacitance? Okay, this is my voltage divider configuration. Okay, we still have physically we still have the CS, CC and CE, but in AC it will be short here, will be short here, and it will be short here, and another capacitor will be appear, which is CBC from B to C, CBC, and then CBE here from B to E, and we have CCE from C to E. Okay, we have these three capacitors, and another two capacitor at the input side is CW in here, at the output side CW out. Okay, please take a look at this CBC. Okay, this CBC is actually this is the voltage divider. Okay, for voltage divider, okay, the CBC is act like a feedback capacitor in the inverting amplifier. Okay, this is example of the inverting amplifier. Okay, we have our amplifier here. So your amplifier here is like this. You have this one, and then you have another capacitor connect here. Okay, so it's like this from here to here. Okay, so because of this capacitor, the CBC, or we call it feedback capacitor, we will use Miller, we name it Miller effect, to solve the equation or to solve the calculation for the CBC. Okay, because this CBC is connected at the C and B, and it is difficult to solve this calculation. Okay, I will explain in the next slide. So for the high frequency response, we have this condition, and we use Miller effect capacitance, okay, in this frequency calculation. Okay, take a look here, the frequency response with the interelectrode and wiring capacitance.